Hello everyone. Today we are going to solve LeetCode problem number 2379, which is minimum recolors to get k consecutive black blocks. Here you can see the problem is marked easy on LeetCode. The problem is you are given a zero indexed string blocks like this. This is this index. This index is given, not index. This is the string. String blocks is given of length n, where blocks of I is either w or b. W or b. Every character is w or b, representing the color of the ith block. Of the ith block means the characters w and b denote the colors white and black. W means white and b means block. That means the first block is colored as white and the second block is colored as black, and so on. You are also given an integer k, which is the desired number of consecutive black blocks. In one operation, you can recolor a white block such that it becomes a black block. Return the minimum number of operations needed such that there is at least one occurrence of k consecutive black blocks. In this example, you can say k is equal to 7. You have to return the minimum number of operations required to make 7 consecutive blocks black. If in this example, let me explain this example more. You can see in this example, this is the index. Let me give the indexes. This is 0 index. Let me make it small, and this is 0 index. This is index 0, this is index 1, this is index 2, this is index 3, this is index 4, this is index 5, this is index 6, this is index 7, this is index 8, and this is index 9. So there are 10 characters, and you can see from the beginning, from here, if you extract this 7 length substring from 0 to 6, right? In this string you can see that first one is white, then black, white, black. So you have to color the white blocks as black. So if you color this white, then you can color this white as black, and this one, and this one, and with the if you color this and this white blocks as black, so you will get this substring as the whole substring will be black box, right? Will be black blocks consecutive. This is the 7 length, and all the characters will be black if you color these 3 white boxes. So here the answer is 3 for this substring. Now let's go to the next substring. If you go to this substring from 1 to 7, this substring, you can see that there are white, three white blocks. You have to color these 3 white blocks in order to get this whole substring as black, as all blacks. So here the answer is 3 operations you have to perform in order to make this whole substring black. Now let's go to the next substring. Next substring means from here, from 2 to 8. In this substring you can see that this is white, and this is white. You have to color these white blocks as black. So here you have to perform 3 operations in order to get this whole substring black. So here also 3. Next, from here, from 3 to 9, this is 7 length, and here you can see this is white, 2, this is white, 4. There are 4 white blocks. You have to color all the 4 white blocks black, so that you can get this string as black, all black. So you have to perform here 4 operations. Previously 3, and here it is 4. So the minimum operation is 3. That's why the answer is also 3. So you have to solve. This is the most brute force approach. In brute force approach, what you have to do? What do we do? Here, what did we do? We first is uh, calculate all the substrings of length 7. Calculate, calculate not. Search in all the substrings of length k. This is k of length k, and then compare. Then second step will be then find the minimum operations, right? This will be the brute force approach. So if I code this brute force approach here, let me code this again. I have solved it already. Let's code this again. So I have to traverse the blocks string for int I equal to 0 and I should be my less than equal to n minus k, because you have to go if you have to go till the k length substring is possible. If there are not k substrings, then you don't have to go further. That's why I have written n minus k here. That's why I am not going to till the end n. Then I plus 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 then I plus plus. Go through all the substrings. Now from here, starting from I, count the number of whites in that substring. How many white blocks are there? You have to count. So make a variable int w equal to 0. Now calculate int j equal to 0 and check if the length is j minus I plus 1 is less than equal to k and j plus plus. If the length is equal to k, then stop the loop. Then you can stop the loop. And in that particular substring, check if blocks of j is equal to w character. If my current block is white, then increment the w variable, and for my current block, and let's create another variable called result. Result will be equal to store it as -1, not -1. This will be maximum, like infinity, int max, this one. Now for every substring you have calculated the number of whites. Now compare it with the previous one. So result will be equal to minimum of result will be equal to minimum of result, comma w, right? Length, how many whites are there, the w, and previous result, because you have to return the minimum answer. So this will do it. Now next return your result. Now next return the result, overall result. Okay, so let's run this. Okay, let's see what did we do wrong. Okay, n, we haven't specified what is n. So n, what is n? N equal to blocks dot size. N equal to blocks dot size. Let's run it. This should run. Again wrong answer. Let's see, output is 1, expected is 0. Why? Let's see, k is 2, so I will check here, then I will check here. Expected is 0, so what did I do wrong here? The expected output should be 0. Why this should be 0? Because to length, here you have to color this white block as 1, so there is 1 operation, minimum 1 operation. Next here this is 2, next here this is 2, so this should be answer is 1. This should have the answer 1. I don't know what is the error here. I have initialized I variable that goes to n minus k, and a white variable, and I am counting my white blocks in that substring starting from j, and length is k. Okay, here I have to initialize it with I, right? So now let's run this. Okay, accepted. Now let's try to submit this. This should be able to pass all the test cases. Yeah, it is passed. Now let's come to the next approach. What should be our next approach? The next approach should be what were we doing previously? We were doing first we are searching in this one, next we are searching on this one. Next we are searching on this array list, next we are searching on this list, next we are searching on this substring. So here we have calculated the minimum operations. Now we are calculating here in this substring the minimum operations. So you can see that this is a problem of sliding window. We can solve this with the help of sliding windows, because this is the window and this window is sliding towards right by 1 character every time, this one. So if we in this in this window, if you calculate the number of operations, which what will be the operation, the number will be 3, right? In the first window the number of operations will be 3. Now if you move this service window to the right side by 1 character, then you have to decrease this by 1, right? Because 3, what was 3? Number of operations, which basically means number of whites. So there are 3 number of whites. So you are moving this substring to the right, so this white is getting rejected, neglected. So that's why I am decreasing it by 1. So I have decreased it by 1, and here you can see my w this is incoming, this is accepted in my new window, so the plus 1, which will be equal to again 1. You can see in this window the number of w's are 1, 2 and 3. Number of w's are 3 in this window, right? In this window. So this is how we can solve this in with the help of sliding window. So approach 2, you can solve this with the help of sliding window. So let's code this. So what should be the approach? Okay, we will need the result variable, n variable. Let's erase this, and let's code the sliding window. Okay, so while first initialize I will be equal to 0, right? And int j will also be equal to 0. Now while j is less than n, while j is less than n, if blocks of j, if my current character is equal to w, if my current character is equal to w, then again take a variable that will store the count of whites in my current window. So do w plus plus, right? Next, j is increasing, so if the length of the current window, and what is the length of the current window? J minus I plus 1. This is the length of the window. If this becomes equal to k, if this becomes equal to k, then what do we have to do? If this becomes k, then I have to update my result. Result will be equal to minimum of previous result, comma, my current count of w, my current count of whites, right? So you calculate the result. Now you have to go to the next window. In order to get to the next window, what do we have to do? We have to update the I variable. So if and while I am updating, first check if blocks of I, if blocks of I is equal to w, right? Ith, at the ith position, if there is a white block, then decrease the white count, right? We are doing this here like this. Here the ith value was w, that's why we are decreasing my result by 1. That's why I am decreasing this, decrease my this count variable of w, and the next increase my I, which will be I plus plus, and at the end my j is going right side. Okay, and in the end return the result. Let's run this. This should be accepted. Okay, accepted. Let's submit this. This should be able to pass all the test cases. Yeah, so this is how you can solve the problem using sliding window technique. So let's talk about the time complexity. In the brute force approach, what was the time complexity? In the brute force approach, the time complexity was big O of n multiplied by k, right? Because in the brute force approach, we are searching all the substrings of length k. For first character, in this substring we are searching of k length, and for second character we are searching in this length k length, and for third character we are searching in this substring of k length. So for all the characters we are searching for n length substring, k length substring. So how many characters are there? For for n characters we are searching in k length substring every time. That's why the time complexity is big of n into k. And what is the space complexity? The space complexity is big of 1, because we are not using any other variable. So this is the time complexity and space complexity of the brute force approach. Now let's come in the sliding window. What would be the time complexity? You can see here we are using only one while loop, j is from running from 0 to n. So 0 to 1, and each time this will take order of 1 time, and this will also take order of 1 time. This if block will take order of 1 time, this will also take order of 1 time, right? So the overall time complexity of the sliding window approach will be order of n. Sorry, time complexity will be big O of n. And what will be the space complexity? The space complexity will be big O of 1, big O of 1, because we are not using anything here, anything array like. That's why the space complexity is big O of 1. So that's all. This is how you can solve the problem using sliding window. That's all. Thank you.